Hey, what's going on? We'll just wait here for a couple minutes while people start trickling in. Feel free to throw some GMs in chat if you're excited. While you're at it, why don't you guys throw in chat where you guys are tuning in from, just to see where everybody's at. I'm personally in San Jose, California, but let's see where everyone else is at. We'll just wait for a couple minutes while everybody comes in, and then we'll get started. See, we get more people coming in. So as I was saying earlier, if you guys are watching right now, feel free to throw in where you guys are tuning in from, just to see where everybody's at. Let's get some GMs going. All right, we're getting more people in. Hey, there we go. Where are you tuning in from? I'm in San Jose, California. Are you guys excited? Ready for the first day at FastCamp? It's going to be fun. We're going to go over some demos today, go over what to expect from FastCamp, as well as some of the blockchain and crypto basics. We'll just get started at maybe in a minute or so. There we go. All right, I guess we can just get started. So yeah, hi everyone, I'm Shane. I'm the developer advocate here at Decentology, and yeah, let's get right into it. So first, what exactly is FastCamp? So the Hyperverse FastCamp is essentially a mini bootcamp designed to help you guys, right? Help Web 2 developers to start building for Web3 using the Hyperverse. And I'll explain exactly what the Hyperverse is a little bit later. But yeah, we'll be hosting FastCamps for Ethereum, Metis, and Flow, and also any other blockchain that get integrated into the Hyperverse. So yeah, essentially we'll be going over all the basics you need to know about that specific chain that the FastCamp is for. So in this case, Ethereum for this one. And then as well as how to start actually developing Dapps on them using only JavaScript. So no smart contract code needed at all. So what exactly are the benefits of completing the FastCamp? So you can actually earn a FastCamp NFT after completing it, which you can see rendered on the right. And what that allows you to do is actually get certified and be able to apply to paid bounties. And then you'll also be able to win some cool merch and other prizes, and possibly become a community ambassador for the Hyperverse DAO, which also has some monetary benefits to it as well. So yeah, let's get right into it. So for the agenda for today, we'll be going over the Hyperverse overview, just like what it is, and then as well as some of the blockchain and crypto basics. that you need to know to actually start building these Dapps. And then I'll show you 2 live demos of 2 example Dapps using some of our smart modules. And then as well as we'll like look into the code and everything to see how everything is working. So yeah, let's get started. So first off, what we're essentially building is a community-built, open and audited modular platform for smart contracts for all major blockchains. So I know that's a mouthful, so let me break it down for you. So essentially, right now, how someone builds these Web3 apps is someone builds a the smart contract aspect and then the client-side aspect. So to build the smart contract aspect is you would need to know some other programming language, say for instance, Solidity, Cadence, or Rust. But also building smart contracts takes a different level of experience and set of skills that's different from building a Web2 app, just because of the the sole nature of like the infrastructure. So one of the most important things is like when code is pushed onto the smart contract, that code is immutable. It can never be changed. So that requires a different way of thinking than the regular Web2 world. So essentially what we want to do is make it super easy and simple for any Web2 developer to build these Dapps using tools that they're familiar with, like JavaScript. So without writing a single line of smart contract code, they can go on and actually build these Dapps. So here's like the basic infrastructure of the Hyperverse. So we have these smart contract developers that actually build these smart modules. So essentially what these smart modules are packaged up smart contracts that are single purpose and on chain. And then they build these smart modules and it's sent to our community of registrars. So what these community of registrars essentially do is validate these smart modules to make sure that they have the proper documentation, examples, as well as metadata and stuff like that. So once they're actually validated, it will be passed on to the community of auditors. What these auditors will do is actually take a look at the smart module or smart contract code and see if it is trustful. So by doing this, they will actually stake their tokens in order to confirm that, hey, I think this is trustful. And by doing that, the stake actually acts as an insurance layer for these smart modules. So when a Web2 dev, comes in and uses these smart modules however they like, they pretty much know that it is secure because, maybe 10, 20, or 30, 40 auditors have actually staked their tokens to confirm that, this smart module, this code is actually trustful. So now on the Web2 developer side, all Web2 developers have to do now is, use our JavaScript libraries that tap into these smart modules and wire up these smart modules, these functionalities, however they wish throughout their Dapp. So, if this sounds familiar to you, it's because it is, right? If you want to build a payment layer in the Web2 world, you wouldn't build it from scratch. You would use Stripe, 2 to 3 lines of code and you're done. So you're using very specific functionality. An app also has like, say it has Stripe and Twilio, you would use both those services in combination in 2 to 3 lines of code and you have them both working. So essentially this is exactly like that. It's exactly like Lego blocks where you can use different smart modules for different purposes throughout your Dapp. So we are building the NPM for smart contracts and it really is that easy. No smart contract code knowledge needed at all. So maybe before you were coming into this, or maybe you're thinking right now that, do I really have the skills to build these Web3 applications? And I'm here to tell you that you absolutely do. As long as you know JavaScript, you are very capable of building Dapps for Web3. So the code would be written in simply HTML, CSS, and JavaScript, and then you could have frameworks like React, Vue, or any other framework really, and all you would be doing is just tapping into these smart contracts that are already built by smart contract developers and using those throughout your app. So it's very easy and you're fully capable of building these Dapps. So now let's get into some of the blockchain basics. So first we'll actually look at a comparison between the Web 2 versus Web 3 architecture. So here you can see a diagram of a user trying to access a centralized application on their mobile or desktop device, whether it be accessing a website or some sort of information. This request is then sent to the centralized web server, which is then further sent to an API server, which is further sent to a database server. Once this information has actually been accessed, it will go right back down the line back to the user that actually requested it. So it would go back to the API server, back to the web server, and then it would show up on the user that requested that information. So now let's look into the Web3 architecture. So here we have a user trying to access a decentralized application, that was built with HTML, JavaScript, and CSS. So what happens is that this request is actually sent to the blockchain, which is decentralized, to a specific node that's on the blockchain. And then once it finds that information, it will return back, go back to the user, and pop up that information. So now that we have a quick overview of the infrastructure of Web3, we can look into the actual workflow, the blockchain workflow. So someone will actually request a transaction. Now what happens with this transaction is that it's then broadcasted to a network consisting of computers, which are also known as nodes. What these nodes will do is actually validate the transaction. And once the transaction has been verified, it will go onto a block of data along with other users and other transactions. And then that new block will then be added to the existing blockchain where it will stay permanent, right? It will be there forever. It's cannot be changed. And then the transaction is complete. So now let's dive a little bit into some of the crypto basics. So the first thing we'll look at here is the public and private keys. So the first thing that is generated will be the private key. How it is generated, it's some fancy math stuff, which we won't get into right now just for simplicity's sake. But essentially what you need to remember about private keys is, it is private, so it's not meant to be shared. And then from the private key, including some, even more fancy math stuff, is how the public key is derived. Now, this key can be shared with anyone if you wish, but private key, private, public key, public. That's pretty much the most important part that you need to remember out of this. If your private key gets out to anyone, that is essentially how some of these hacks happen in your wallet, where someone can do anything essentially with your private key. So now let's look at these blockchain accounts. So, these accounts on blockchain are not, made like they are in the Web 2 world. So these blockchain accounts are instead derived from your public and private keys. So that's how these blockchain accounts are created, not anything similar to the Web 2 world. So now let's actually look at a real life example here of Bob and Alice signing and receiving messages. So here we have Bob who is using an application to sign his message with his private keys, which will create a signature and it will send that signature to Alice. So we're not sending the private key. We're not doing anything with the private key besides creating a signature. And that signature is sent to Alice. So once Alice receives that, Alice can then use the app to verify that this message does belong to Bob by using his public key to essentially verify that. So Bob could give their public key to Alice, and then Alice inputs that public key and would tell them if this message is in fact from Bob. So now let's get into the tool that actually handles and does all these transactions and this private key, public key stuff. So these wallets essentially do two things, right? It's there to secure the storage of your private keys and also to sign transactions. So it is important to note here that a blockchain wallet does not contain any money or crypto. It is specifically there for those two reasons, to secure your private key and to sign transactions. So with transactions comes fees. So we'll be going over the three concepts of these fees, specifically just the transaction fee itself, the gas prices, and then as well as the speed of these transactions. So the transaction fee itself, which is often called gas, you can actually specify any amount that you wish, and you'll see later in the transaction speed that the higher the amount, the more likely that your transaction will go through quicker than someone that had put in a lower amount for their gas. But as you can see here, the amount you wish, but if the transactions with very low gas are likely to be ignored. So yeah, let's go into the gas prices. So the gas price itself is very dynamic, and it varies according to how many other people are submitting transactions at that time. So it fluctuates a lot, just depending on how many transactions are going on. And then the speed, like we had mentioned earlier, right? So higher gas fees are likely to be processed faster than those with lower fees. So now let's do just a quick overview of fungible versus non-fungible tokens, and then we'll actually get into the live demo, and we'll look into the code and everything like that. So non-fungible tokens are not interchangeable, and fungible tokens are interchangeable. So what does that exactly mean? So for instance, if you think of a dollar bill, right? If I were to give any one of you a single dollar, and say if I asked for it back, you could give me any other dollar out of your wallet, and I wouldn't question it, right? I don't need that specific dollar bill. So that's where fungible token comes in, where it is interchangeable. It's still the same value to me. A dollar is still a dollar. And another example of this would be Bitcoin. So non-fungible tokens are not interchangeable. So for example, art pieces, NFTs, all that stuff. So if I were to give someone, if I had the Mona Lisa and if I gave that to someone and asked for it back, and they wanted to give it back to me, they can't give me any other art piece, right? It is the only Mona Lisa out there. Well, in this case, it would be, say for NFTs that are digital, if I gave someone, a Bored Ape and I asked for it back, I would want that same Bored Ape back because it is totally different on chain to any other Bored Ape, right? It's all unique and distinct. It has totally different metadata, token IDs, all that stuff, right? So that's where the non-fungible aspect comes in. So yeah, now let's get started with the demo, the fun part. So first thing here, we'll actually look into the docs.hyperverse.dev. So if someone wants to throw that in the chat, so you guys can actually follow along with me here. So we'll actually be looking into the build Web3 apps environment setup. So the first thing here we'll look at is the system requirements. So making sure you have VS Code or any other IDE for editing JavaScript downloaded, as well as Git, Node.js, and Yarn. Here are two different ways that you can go about actually getting yourself set up and hooked up to the Hyperverse. The one that I'll be showing you today is using the Hyperverse monorepo, but you can also start from scratch and use the generic npm package for creating a Next.js app. So we'll click on using the Hyperverse monorepo, and you would simply copy this, paste it in your terminal. What this will allow us to do is actually clone the Hyperverse monorepo, which gives us access to automatically to all the example dApps that are there, as well as a packages folder, which basically just includes all the smart modules that are available for you to use and mess around with in all of your dApps that you're building. So next, we'll actually go into the Tribes folder. So Tribes will be the first example dApp that I will be showing you. So right after you're in that folder, you would simply call yarn to install these dependencies and then run yarn dev. So if I pull up my terminal right here, we can actually go into the Hyperverse monorepo. And then from here, we would go into apps, just like it said in the documentation. And then here, we're specifically going into Ethereum because that's the chain we're working on today. And then we'll go into Tribes, since that is the example dApp that I will be showing you today. So now from here, you would simply run yarn on your machine first to install the dependencies, and then run yarn dev. So now we can have this up and running on our localhost. So here we'll just let it load, and then we can actually cancel out of this for right now as I explain exactly what Tribes is and all. So essentially what Tribes is a it's an example Dapp that allows users to join, leave, or create tribes. So it's all using a smart module, but everything is happening using JavaScript. So it's also important to note here that all of these tribes are mutually exclusive. So you can only be in one tribe at a time. But you can think of these tribes as anything like sports teams or anime characters or any sort of group that can have members and people can join. So the first thing that a user will do when they get on this app is try to connect their wallet. So once they click Connect Wallet, you'll see a pop-up here, which will ask the user which wallet provider they're using. So in this case, we'll be using MetaMask, and I have the MetaMask wallet extension downloaded as well. So what will happen after I click MetaMask is it will pop up the MetaMask wallet extension and ask us to make sure that you do want to connect to this app. Once we click Connect, you'll see our wallet address pop up on this button right here, and we'll also see a button pop up right here called Join a Tribe. So let's go ahead and do that. So let's click Connect Wallet. You see this wallet pop up. It's just asking which account. So I'll choose that account. Here's my wallet address. And it's just asking if you want to allow this site to see the address and stuff. So we click Connect. While it's connecting, you see that the wallet address pops up, just a shortened version of it, and then as well as Join a Tribe button. So now what will happen when I actually click this Join a Tribe button is that you'll see processing. So what this is doing is actually fetching from the smart contract from on-chain the data that is available for us to use. So the tribes that are available for us to join. So you'll see processing, and it's basically just doing like a GET request, right, in the Web 2 world. So it's fetching, using JavaScript, fetching the data that lives on-chain and showcasing that data. So let's click Join a Tribe, and you'll see that it's processing. After it's done processing, you'll see which tribe do you want to join. So here are all the tribes. Now, a quick thing to note here is that when we're actually about to click on a tribe, it will actually join a tribe. So because we are joining a tribe, we're actually updating or putting information on the blockchain. So whenever we are updating or putting information on the blockchain, it costs money. It is a transaction. So before you saw where I clicked Join a Tribe, we weren't updating any information from the blockchain. We were simply reading, so fetching. So that won't cost any money and that won't be a transaction. In this case, since we're actually putting information on the blockchain, it will cost money, causing the MetaMask extension to pop up and confirm the transaction amount. So you'll see here in just a minute where I'm going to click Dragon, and you'll see the MetaMask wallet extension pop up. It's asking us to confirm, so we click confirm, and then it'll be processing and show you the tribe that I just joined. But for now, let's actually click back into this MetaMask and actually look at this transaction on the Block Explorer. So here's a bunch of blockchain heavy stuff. You don't necessarily need to know all this. It does everything for you on the back end, but it's definitely good knowledge to know. So here you'll see the transaction hash. So this is how you can look up the transaction. You'll see where it's coming from. So this is the wallet address that it came from. Who did it interact with? So if we actually click on this contract address, you can see here all the previous transactions. This one is currently the one we just did. So you can see all the information regarding that. All this is happening on the Rinkeby test network. So yeah, you can see the value, the gas price, all that cool stuff. So now let's go back, and you'll see right here in this my tribe, the tribe that I just joined. You see the image, you see the title as well as the description. So now you can guess here what will happen when I click Leave Tribe. Since we are updating information on the blockchain, it is a transaction, so it will cost money, and the MetaMask wallet extension will pop up asking us to confirm. So we can click Leave Tribe. It will ask us to confirm this transaction, and then we'll be back onto the home page. So now I will actually open up VS Code, and let's actually look into this app and see how everything is actually working. So we can actually go into the apps folder like we had done earlier in the terminal, go into Ethereum, and then we'll go into Tribes for this example app. From here, if we go into the source folder, pages, app.tsx file is the first file that initiates all of this, and this is where the Hyperverse is actually getting hooked up to this app. So from here, you'll see a couple things. So first thing we're actually importing is some blockchain specific stuff. So this initialized provider, network, Ethereum, all this does is gives us access to some blockchain specific functionalities, as well as give us access to the user's wallet address, the chain they're on and stuff like that. So the first thing that we do to actually hook up the Hyperverse is initialize the Hyperverse. So in this couple of lines of code, all we are doing is telling it which blockchain. So Ethereum, we know we're using Rinkeby testnet, so network.testnet. Storage here is optional, so it's not necessary to be here. So technically you only need blockchain, network, and modules. And in this modules array is where you can add as many modules as you want. So when we talked earlier about wiring up different modules for different functionality, this is where you would do it, right? So you could just import many other modules as you wish, and then just tap this into this array. So here we're just specifying which module that we imported. So Tribes in this case, that's the one we will be going over. And then here all we are doing is wrapping our entire application with the Hyperverse provider, giving it access to the Hyperverse. And then a quick thing to note here is the architecture of the Hyperverse. So you see here is the tenant ID. So you're probably wondering, where did these tribes come from when it was showcasing all of the tribes, and how can we change it if we wanted to? So here, this is the address that is actually pulling the data from. So that's why we are passing in the tenant ID here. So say, for example, if you actually wanted to upload your own tribes or your own images, your own description, your own names, then you would actually just change this to your own wallet address, whichever wallet address you're using, and then you would actually go to a different route. So you saw what we did here, but you could essentially just go to /setup, and it'll tell you here how you can create a new instance of several other tribes that you wish to have. But for now, we'll just go back to the home page and look into the code. So first page that is rendered is the index.tsx. So here we'll see that the first component that is being rendered is this nav. So if we actually look into components/nav, we'll be able to see how this first functionality is even working. So as you saw here, we see this log out and connect. So what this connect wallet does is essentially just call this connect function when a user clicks on it. So when a user clicks on it, we call this connect. Where is this connect coming from? It's coming from this use Ethereum hook. So all we are doing up here is importing use Ethereum, which gives us access to these functionalities, right? It says connect, disconnect, address, chain ID, so all these wallet specific things. And then here we're just extracting these functionalities from the use Ethereum hook for us to use it throughout our dApp. So connect will simply connect, so it'll do all the pop-up for you, authorize and connect the user's wallet, and then disconnect will simply disconnect the user. So here all we are saying is that if there is an address, so if someone is logged in, we would have an address. So if there is an address, then we're just going to show a shortened version of the wallet address on the button itself. So when we click connect wallet here, we see this shortened version of the actual wallet address. And then when there is no one connected, then we just display connect wallet. So now let's go back to this index.tsx file to see what's going on. So the first thing that happens is that we click this join a tribe button. So what that does is that pushes us to the all-tribes router. So we saw this route change to all-tribes. You'll see it here. And essentially the infrastructure of Next.js is that it will actually go to all-tribes file. So the routes are matched with the files. So if we go to all-tribes, we can see here how exactly do those tribes get pulled. How exactly is that data getting pulled and fetched and displayed onto the site. So we see here is that we're mapping through something called data. And then as we're mapping, we're showing an image for each one. So this is the tribes images, right? And then as well as displaying their name. So where is this data coming from and how are we getting it? So if we move up here, we'll see data is being extracted from this tribes function. Now this tribes function is being extracted from use tribes. So this use tribes hook gives us access to several different functionalities that are tied to the smart contract. So essentially it's a bridge between the smart contract and the front end code. So it's extracting all the smart contract code into JavaScript. So you can see here that there are 8 more functions. So this can act as kind of like your API layer where you can do in the Web 2 world where you can do like fetching, putting, and all that stuff. So it handles all that for you. All you got to do is simply, in this case, call tribes, and then we extract the data from the object that is returned, and the data that is returned is essentially a list of the tribes that are available. So then we're simply mapping through that data and showing each of those tribes. Now, once we actually click on a tribe, as you saw, we are joining a tribe. So all we are doing there is calling this mutate function, passing in this ID of whichever item that you had just clicked on, whichever tribe that you just clicked on. So what are we doing with this mutate function? So all we are doing is calling join. So it does everything for you. It does the transaction, it updates the data on the blockchain, everything for you. All you got to do is call join. And then once it's successful, we're going to the my-tribe route, or in this case, the file. How does this join get imported? The same exact way. We're just extracting it from the use tribes hook and then using it the same way as we did with tribes. So now let's go into my-tribe. So here you'll see a very similar pattern. So when we actually joined a tribe, right, we had to sign this transaction, and then it showed us the information of the tribe that we had just joined. So the the image, the title, the description. So how are we pulling that? So it's very similar. Again, we're just extracting this tribe now instead of tribes from use tribe or use tribes. And then all we are doing is when we call this tribe is we are extracting this data. Now this data consists of the information of the tribe that you just that the user is currently in. So all we are doing is displaying the data.name, data.description, and the data.image, which gives you the image, name, and description, which we have right here. So now how do we actually leave a tribe? Now you could probably guess it's very similar to joining the tribe, right? Since they both are transactions, they're both going to be updating information on the blockchain. So now you can see right here the button to leave tribe, and all we are doing is calling this mutate function. What this mutate function is doing is calling leave, and then once that's successful, we're just pushing the route back to the homepage. So that's pretty much it. It's very easy, very simple. Everything done through JavaScript, as you can see. You only got to call a few functionalities, and everything's handled for you on the back end. So now we can actually switch gears and go into the ERC-721 module, which is essentially an NFT. So what we can go here is pull up the code for the ERC-721. I'll actually minimize this and show the ERC-721 module. So we can just cd out of tribes, and you can see here the list of other example dApps that we have. So in this case, we're going into the ERC-721, and then we simply want to run yarn dev. So now we can minimize this and refresh this. Since it's on /my-tribe, we just need to do that. There we go. So right now we are connected. Let's just disconnect. So here you see kind of like a dashboard of all the functionalities that you can do within this smart module. So You see here that you can get the total supply. So whatever NFT that you have created, you can see the total supply of that NFTs, as well as get the balance of whoever's connected. So how many NFTs does this user that's currently connected have of this specific data, and then as well as get the balance of any accounts. You can put in a wallet address, and it would show you how many of these NFTs that user has. Now all of these are obviously disabled because we have to connect. So let's connect our wallet, and now we can see all this stuff. So you could see 1 as the total supply. This current user has 0, and then you can as well as mint NFTs and transfer tokens. So as I explained earlier about the architecture of the Hyperverse and the tenant ID, so you can see the same thing happening here. So here you would create your own instance, and then you can update the code with your wallet address so that it shows all the data regarding the the token that you created. So you can imagine right now that someone else has created their own instance, and that's the data that we're looking at. But now say we wanted to create our own instance. Well, let's do that right now. So let's go to our MetaMask extension. Let's actually create a new account. Let's just call it tenant. So let's create this account. And you'll see here that we have 0 ETH. Now, to create a new instance or even to mint an NFT, we would need some sort of ETH because it will be a transaction. So a good place that I like to go to is this faucets.chainlink. So here we can simply connect our wallet. So let's make sure that we're connecting tenant. So let's go to tenant, connect wallet. We can click connect. And then we'll just request for test ETH. So let's send this request through. And then while this is confirming, we can quickly go back here and talk more about this. So what you'll see here is that we'll actually create an instance. So for example, let's just name it Shain Codes. That's my Twitter handle if you're wondering why I'm using Shain Codes. And then the token symbol, we can just do SC. So once we have that test ETH, we'll actually connect our the tenant wallet to actually create this instance. And then we'll go back in the code and update the tenant ID to that wallet address, which will then, you'll see here 0 as the total supply, and then you'll see 0 here as well. Why? Because we haven't minted an NFT yet, so there are no SC tokens out there. And then once we mint it, you'll see the number go back to 1, and you'll also see the balance of the current user go back to 1. So let's check back here. It has been completed. We can double check over here as well. Tenant, let's just connect our tenant, and you see 0.1 ETH. Nice, we're rich. So let's just make sure that this is the wallet address that is connected. It is. And let's create this instance. So we're creating this instance, which is a transaction, and we can go ahead and confirm this transaction. And we can also look at the actual transaction that is pending. So we can go here on Block Explorer and see again the hash, who it's from, who it's going to, all that good stuff. So let's go back over here, and then we can actually open up VS Code and find exactly where this tenant ID attribute is. So everything starts from the app.tsx folder, so we can go to the pages app.tsx folder. So you'll see right here is the tenant ID, right? So everything else is very similar, right? We're still initializing the same way. As you can see here, we're not using the storage parameter since it is optional. So this will still work perfectly fine. And then instead of this specific tenant ID, we just want to put in the wallet address we just used to create our instance. So we can go here, and then we can copy this tenant wallet address, and we can paste that in here. After I save it, you'll see it is updated to 0. So there are no SC tokens out there. So what we can do is actually mint this NFT to myself or someone else. For the sake of this, I'll just use the same wallet address. So we can go ahead and mint, and then you'll see the transaction pops up. We click confirm, and then you'll see the total supply will be 1, and the balance will also update to 1. So we can actually go check out this on the Block Explorer as well. And yeah, you'll see who it's coming from, the transaction hash, all that stuff. But you'll also see, once this gets updated, you'll see the actual token as well. So let's, there we go. So we see that the balance is updated to 1, total supply is updated to 1, and say we actually wanted, just to double confirm or just for fun of this function, we can see, finding the balance of a specific wallet address. So we'll just use ours, and you'll see that, in fact, there is one. And then we can actually put in a token ID as well and return back the wallet address of who the owner is. So in this case, since there is only one token out there, it starts off with 0. So we can put in 0 as a token ID, and you'll see the actual wallet address pop up. So now we can actually go ahead and look at actually transferring this token to someone else. So let's get rid of this, and let's find another wallet address to transfer to. So let's just transfer to this account. So let's copy this. Make sure we go back to the tenant account, since that is the one that is transferring that token. So we have to be logged in and connected to the Dapp with that wallet. So now let's put that as the receiver. Which token ID would you like to transfer? We can put 0, since that is the token ID. We click transfer, which is a transaction. We can click confirm, and you'll see right there that it did say SC. So we can actually go here. So SC is the token symbol, right, that we had put in. And then if you actually go and view this on Block Explorer, you'll see, once this transaction, the status has been updated, you'll be able to see that the ID and the token information as well pop up on this transaction hash. So let's just wait for that to load. But yeah, until then, you'll see, oh, they're already updated. The balance of the current user is 0. And then if we go here and look at the other user, so let's actually confirm with the user we transferred to. So let's copy this address and put it in here, and you'll see that it says 1. And then as well as here, if we put in 1, you'll see the wallet address is different than the current user, since we just transferred it. So yeah, let's look back at this transaction hash, and you'll see right here. So it literally says, Shain codes SC, the token ID 0, and the token type ERC-721. So you can see exactly, who sent it, who it's going to, and all that fun stuff. So you can see the transaction fee as well. And yeah, so now let's actually look into the code and see exactly how all this is working. So, as I explained earlier with the Tribes Dapp, so it's very pretty much the exact same here, right? We're just importing these blockchain specific modules. We are initializing to hook up to the Hyperverse, and then we are wrapping this provider around the app to get access to the Hyperverse. So now the first file that we look at is the index.tsx, and you see here that the component that's being first rendered is the nav. So again, very similar to Tribes, we can go into components in the nav file, and you'll see here that we're doing the same sort of functionality, right? The connect wallet button, which allows the user to actually connect to the Dapp, and then as well as log out. So again, we're just importing this use Ethereum hook, and then with the one line, we're just extracting the connect and disconnect functionality, as well as getting the address. And so now let's go back to the index.tsx file and look into this container component. So here you'll see all these several different components that are being rendered to showcase the functionality of the smart module. So the first one we can actually look into is this mint NFT. So if we go into there, we can see how exactly it's working. So before I was connected, you could see that the button on the mint NFT said connect wallet, right? So if we were to log out, you see that the button says connect wallet, and then when we're actually logged in, it says mint. And then the other thing that is required is the input, right? where is this NFT being minted to, or who is it being minted to. So either we put in this case, our address, but we can put in someone else's address as well. So all we are doing here is setting this receiver, so this receiver variable to whatever the user puts in as the wallet address. And then once the user actually clicks the mint button, we are calling this mint an NFT function. So all this function is doing is calling mutate. Now, where are we getting this from? We're getting it from this mint NFT function. So very similar pattern to what we had seen earlier. This mint NFT function is extracted from the use ERC-721 hook. So what this hook allows us to do is just like the use tribes hook, right? So it's essentially giving us these 6 plus 1, so 7 functionalities of things that are extracted from the smart contract into JavaScript, where you can simply do GET requests or PUT requests and all that from using just JavaScript. So yeah, we extracted mint NFT, then we call mint NFT and extract this mutate. And then once a user actually clicks on the mint button, we are passing in this instance data object, which is just passing in who are we sending the NFT to. So either minting it for yourself. So this is just the wallet address that we had put in for ourselves. And so now we can actually look into transfer. So this functionality right here, this transfer tokens, we had put in an address and then as well as a token ID. So those are the two inputs that are here. So all we are doing is setting this token ID, right? We're just updating the state of the token ID and then updating the state of the receiver of the wallet address and then whatever token ID is there. And then once we click on the actual transfer button, we are calling this function, which if we go up here is calling mutate, and it's passing in, from, so who is the NFT from, so the current user that is logged in, their address, and then who is it going to, and then the token ID. And how are we calling this mutate function? We're calling it from the transfer function that we're getting from use ERC-721 hook. So it's very similar, very easy, same sort of pattern, and everything is happening just using JavaScript, and it's still calling all the functionalities on the smart contract, updating blockchain data, you're fetching blockchain data, all just by using JavaScript. So yeah, that's the two demos, and let's jump back into the slides. So here's just a quick overview of FastCamp once again. So tonight by 11:59 p.m. Pacific is the first checkpoint of actually submitting your Dapp ideas. So on the next slide, you'll see exactly how, step by step, how to actually submit your Dapp ideas, but it'll be on GitHub. It'll be simply a pull request to one of our repos. In this case, it'll be the Ethereum FastCamp repo, and you'll just be adding on, your Dapp ideas that you wish to work on for this FastCamp. And then for Friday and Saturday, we'll be hosting office hours from 9 a.m. to 10 a.m. Pacific. This will all be happening on Discord in our office hours channel. And then for the rest of the days, it will just be working asynchronously on your Dapp. And we'll always be there on Discord, so you can always chat with us, ask questions. Even today, if you already submitted your Dapp ideas and just want to get just a quick overview of what exactly you're thinking to do, or even the tech side of things, then you can always hit us up on Discord at any time. And then Monday morning, 8 a.m. Pacific to 9 a.m., we'll be actually doing a after party. So after the FastCamp is kind of almost done, this is where we can all get together, have some fun, just talk, and showcase what we've been working on and stuff like that. And then Monday, 11:59 p.m. Pacific is when you guys will actually submit your Dapp. So here are the next steps. So just making sure that you are on Discord, and then making sure you do submit your ideas tonight. And then the docs link, so the docs.hyperverse.dev, which I was using to show and run up both the example Dapps. And then there's also a great blog post on our Decentology website that basically goes through the steps of how you can build the Wallet Connect on a Dapp. And it goes through building it from scratch. So just using the npm Next.js package instead of using the Hyperverse monorepo. And then you can just start building either today or tomorrow morning. And I'm really excited to see what you guys are going to come out and build for us. So if you guys have any more questions, feel free to throw them in the chat. We have some people here that from our team that can help answer, or I can answer as well. But yeah, thanks guys for being here. I'm really excited to see what you guys are going to build. And please feel free to hit us, any of us up on Discord or Twitter or anything. But yeah. So let's see if we have any questions coming in. We'll be here for a couple more minutes. So we're pretty much on time anyways. And then if not, you guys will be good to go. We'll be sending this YouTube link as well as some resources emailed out to you guys after this workshop. So yeah. Are you guys excited? If you guys don't have any questions, you just chat maybe what you guys are thinking about, how you guys are feeling about FastCamp, anything really. Thank you guys. Thank you guys for being here. If there's no more questions, then I guess I can just end the stream and let it be. You can always hit us up on Discord regardless. Thanks. Thanks, Sheely. Nice. All right. See you guys later. Have a good one. Bye.